guys, so we are working on functions and function notation. So functions are where we have inputs and outputs. An input is like your domain or your x value you put in, and the y value or the output or the f of x or the range value is what you get out. So just like in an ordered pair, when you have an x and y, get this to work, an x and a y, we have functions where we have x and a y. So this ordered pair 2, 4, you know that the 2 comes first because x and that matches with the x-axis, and the 4 matches y-axis. So to write this in function notation, we use f of x. Now f is just the name function. X is a placeholder input. So we're going to say f of x equals y. Now we need to ask ourselves, what is the x and what is the y? I can clearly see the x is 2, the y is 4. So to me, I know I need to substitute. It's 2 for x, and f of 2, and that's going to equal 4. So what that really means is for the specific function. Right now, what the equation is, we just know it's a function. When you put 2 in, you're going to get, that's what we know. So on the other problem that you guys have on your paper, you are given an equation. You are given a function notation. Given a function notation, I don't want to do that. G of x plus x minus 2. So dx equals x minus 2. If you know anything about specific functions, you know that this is a quadratic function because it has a square in it. What we're going to is figure out for these values in the table, x values, we could find any other one, but just for those, plug in the x value, plug in the input to get the output. So we're going to do g, because g is your function name of the first one is negative 2. And we're going to put in x, so it's going to be negative 2 squared minus 2. Now you just do the math. Left side is just going to stay the same because it's saying for this function, what are we going to get? Plug in negative 2. We're not solving for anything, we're just evaluating. So we get g of negative 2, and that's going to equal negative 2 squared is 4, because inside parentheses minus 2. And when we do the math, we get g of negative 2 equal to, so I'm going to put that in the table. Then I can take that order pair and plot. It's going to be negative 2 in the x and 2 in the y. And that points slightly, let me fix it, and that's there. So what we do is we do this function evaluation, substitute in the input every time we need to get the answer. So I just got an order. You need to do the other one. So if you wanted to say you do g of 0, x is 0, equals squared, well 0, so we don't write x, we write 0, minus 2. So g of 0 is negative 2. We're solving for g. We just want to know when we zero this function, when we push this button on this vending machine, what are we getting out? And that's a negative. Now, if you do the math in my head, so that negative 1 squared is positive 1. Positive 1 minus 2 is negative. So for the input of negative 1, we get a negative, or a negative 1. That, since it's a quadratic function, it'll mirror itself. But let's say you didn't know that yet. When I put a 1 in, 1 squared is 1, minus 2 is negative. Some symmetry here. 2, positive 2 squared is 4. 4 minus 2 is 2. And look at that. We have a quadratic function that's got a parabola, because you know that quadratic functions make those which are U-shaped, and my order pairs are a little off. And that's not the right point either. So let me